We now move on from the organizational principles of the last two segments to technical principles. There's going to be three of them, two with sub-principles: develop iteratively, treat tests as a key resource. This is going to be the central role of tests in agile development, and express requirements through scenarios, for which the more specific technical term will be user story. First, develop iteratively. This has two aspects: 6.1 frequent working iterations, 6.2 the closed window rule, freeze requirements during iteration. First, iterative development. Well, if we look at the notion of iterative development, there are two possible interpretations, and let me say right away that the agile view of iterative development is the second one, the horizontal one, in which we have horizontally layered clusters. But it's useful to generalize the discussion a little bit. So one way of interpreting iterative development would be to say, in any system we have a number of technical layers, from the most technical, for example database or networking, to the most user-oriented, such as the user interface. So one way to say we develop iteratively, which is not the agile way, would be to say we start with the most fundamental stuff, because it's going to be the infrastructure on which everything else is built. So we start maybe with a database, then we move on to the networking, then we move on to the business logic. Business logic means what the program actually does, whatever it is, managing accounts for a bank, managing documents for a text processing system, and so on. And then we move on to the user interface. So that's one way of working iteratively, and it's not what the agile view of iterative development is. Instead, we are talking about iterations that each produce a working system, and particularly we're talking about frequent iterations. But each one of these iterations is going to have, maybe in a miniature form, the entire system. So in our example, it's going to have a little bit of database, maybe very rudimentary or just simulated at first, a little bit of networking, a little bit of business logic, and some kind of user interface, but it's already going to be showable to and usable by a typical customer, or a test user, or an embedded customer, if we are using the extreme programming technique. And each one of these iterations includes the entire system, however partial the version may be. Now the emphasis here is on frequent iterations. In the early days of Agile, people were saying something like a few weeks to a couple of months. A couple of months is really the upper bound. Typically, Agile projects use 2 to 4 weeks, I should say 2 to 6 weeks as their standard. In my work, we have adopted iterative development, and the period is 1 month, 1 calendar month, because it makes it easy to remember the January release, the February release, and so on. But in agile projects in general, it varies, sometimes down to 1 week or even 1 day in the more extreme forms. The emphasis is on having frequent iterations and frequent partial deliveries. This notion of frequent working iteration is of course part of the mark that the agile approach has made on the software world. We no longer have very long release cycles as we used to have. At least internally, we have typically a few weeks for a release cycle. Now there's a rule which goes with this, which is extremely interesting. It's what I call the closed window rule. It's my terminology, because although the idea figures in the Agile literature, in particular in the Scrum literature, it doesn't really have a name. But it turns out, even though it's not that much emphasized typically, it turns out to be one of the major contributions of the Agile approach. And what it says is very simple. During an iteration, no one may add functionality. So we take a certain iteration, also known as a sprint in Scrum terminology, and it has a certain list of functionalities to be implemented. For it could be a task list, it could be a list of user stories, which we're going to see in a few moments, which are elements of requirements. So this is what you're supposed to do during the iteration, and of course you're going to try to do all of it. Maybe you'll only be able to realize part of it. The rule says that whatever happens, no one is permitted to add anything to that list. And it doesn't matter who the person is. That could be the CEO of the company or of the customer company. If it has not been planned for that iteration, it doesn't go in. And of course, to be meaningful, the rule has to be applied without exceptions whatsoever. If you start making exceptions, then the whole discipline breaks down. So why is this a good idea? Well, for several reasons. First, it brings order into the process. It means that we know what we are working on and we're not constantly readjusting to new priorities. Second, it only works, of course, with short iterations of at most a few weeks, as we just discussed. Of course, for longer iterations, it would not be sustainable. But here, let's say we have a 1 month iteration period. Well, on the average, what's going to happen for a great idea that has just been proposed, if it's moved on to the next iteration, to the next sprint, on the average is going to be delayed by 2 weeks, which is usually not a catastrophe. And also this has the advantage that there is a certain natural attrition of ideas. It's very easy for someone to say, I have a brilliant idea, this absolutely needs to be done right now, but maybe when you wake up the next morning and the brilliant idea doesn't look so brilliant after all, or at least not so urgent, and so there's a natural phenomenon of sorting of ideas into good, less good, and not really important. So that's one of the biggest contributions of the Agile approach to software development, and I would strongly advise to use this rule. Now, in some cases, a new functionality really is crucial to react to competition, to react to the needs of an important customer. So then there's an escape mechanism, what we would call an exception in programming, but it's rather extreme. We cancel the sprint and we restart a new sprint with a new task list. So it's possible to do this, but of course it's sufficiently drastic that people think twice about going into that solution. The general question is here, how do we compromise, how do we integrate the two kinds of iterative development? Now, the first form, where we build the infrastructure first, the essential functionality, is really scorned by Agilists because it doesn't result in reducible systems right away. On the other hand, it is just good engineering to start by building the infrastructure, the stuff that everything else is going to need, and which it may be a very bad idea, very dangerous to postpone to the end if it's really so critical. And on the other hand, the Agile criticism that is justified, that people often spend far too much time and energy at the beginning without producing any useful functionality. So what one can recommend here, although this is not what Agilists do, is to have what may be called dual development. Early on, despite what Agile texts say, build the infrastructure, build the stuff that has the most risk and that has to be done really right. But don't do this forever. At some point, someone, like the project leader or the product owner in Scrum, should come in and say, okay, enough guys, we have the infrastructure now, it's good enough, so let's actually produce releases. Let's actually produce things that users can get their hands on and tell us whether it's what they want or not. So are we shipping yet? This mixed agile, non-agile approach is, I believe, the right way to go. Next principle, tests. 7.1, do not move on until all tests pass. This is part of the agile approach's emphasis on the importance of testing, and the idea here is that we have what is known as a regression test suite. We will come back to this notion in the discussion of practices. This is a collection of tests that are essential to the project, and one reason that are essential is that all of them, or at least most of them, failed at some point. And we want to check that the failures do not reappear, that the faults do not reappear. And so the idea of this principle here is that it is forbidden to start adding new functionality until we are sure that all existing tests pass, that is to say, all the existing functionality is reasonably well implemented as guaranteed or at least supported by the regression suite. So it's a tough rule because there might be functionality that you think is not so essential, so we'll fix these later, even though some tests are not passing, but it's a really good discipline to say, in consideration of practical constraints, don't move on until everything in the past works. Don't go to the future until the past is clean, and that is part of the emphasis on technical excellence of the Agile approach. There's another aspect to this testing principle, test first, which is also quite important, but we are going to study it later, so I'll defer the discussion to the lecture on practices, the next lecture. The final technical principle here is the notion of scenario, more precisely in the Agile world, user stories. There are other kinds of scenarios, for example, use cases, but in the Agile world it's mostly user stories, and the idea is that user stories are the main form of requirements, or often the only form of requirements in the Agile world. What's a user story? According to Mike Cohn, it's simply something a user wants. Examples would be things like paginate the monthly sales report, change tax calculations on invoices, and so on. There's a standard form that has emerged in the Agile world for representing user stories, these pieces of functionality, as a something. I want something, so that something. The first something is a user or role, for example, a customer. The second something is a business functionality, such as see a list of recent orders, and then there's a business justification. And so a typical example would be, as a customer of an e-commerce site, I, the user, want to see a list of my recent orders so that I can track my purchases with a particular company, be it Amazon or anything else. And the idea of requirements in Agile development is not that you write a requirements document at the beginning. That was the traditional and current approach. It's that you pile up requirements in the form of individual user stories, and then the accumulation of these user stories at the end is going to give you a system as you implement the user stories. But you produce the user stories as you go, not all at the beginning, and then you implement them right away in the following sprint. Here's another example of user story that you can look at in more detail from an article by Waters. As a registered user, I want to log in so that I can access subscriber content. And he writes, I would certainly argue it's more easily digestible. This kind of requirements is more easily digestible than a lengthy specification, especially for business colleagues. Well, sure. Does it, on the other hand, make for the best possible requirements to produce a system that satisfies the user needs? Well, the problem with user stories is that they're examples, so they are to requirements what tests are to specifications, individual examples. To have a little fun, I took in a blog posting the following example. You can read the details in this blog post here. And the question is, I'm giving you a function with some examples, and I'd like you to tell me what the function is. So the value for 0 is 0, the value for 1 is 1, the value for 2 is 4, the value for 3 is 9, the value for 4 is 16. So what is that function? Okay, I'll be kind, I'll give you the value for 5, it's 25. And I had some fun in this blog article to plug these values into curve fitting programs, and sure enough, I find the square function, x square, but we can also get this kind of function here, or we can get this really interesting function that fits very well. So the point of this little fun example is simply to show the obvious, that is to say, examples do not replace a general abstraction. If I tell you this is a square function, I've given you all the possible answers. If I give you a million values, I've still left a lot of ambiguity. And when we do requirements, we need more than examples. We need the abstraction. And the task of the requirements engineer is to go beyond the examples and derive the abstraction. Does it mean that user stories are useless? Certainly not. They're essentially a tool for validating requirements. If you have more general, more abstract requirements, then user stories enable you, like a kind of smoke test or litmus test, to check that besides having a good general description, the system will perform right in typical scenarios. So that is extremely useful, but it's not a substitute for requirements. What we've seen in this segment is a number of principles of Agile development, again, the technical principles, iterative development, the fundamental role of tests, and there's more on this to come, and user stories as the Agile source of requirements, also some of the limits of this reliance, this exclusive reliance on user stories for requirements.